everyone, and welcome to Activity 2. Today we are going to talk about geometric sequences and their explicit formula. If you look at the two patterns in front of us, we notice that there is a consistent pattern, but this time not with addition and subtraction. This first one, we are multiplying consistently by the value of 3. The second one, you may have said that you are dividing by 10, or another way of saying that, that's the same thing as multiplying by 1/10, right? Dividing by 10 or multiplying by 1/10. And again, what we notice about these sequences is the pattern involves either not addition or subtraction, multiplication or division, which is just multiplication, conversely written, right? So if we see here, these show, again, the pattern with multiplication of division, and that is going to be indicative for us of a geometric sequence, right? And if you notice, we call that value that they have in common the common ratio. So similar to how our common difference with arithmetic sequences was 2 consecutive terms subtracted, this time in order to find our common ratio, we're going to take 2 consecutive terms and divide them. So a term divided by its previous term. And again, we would call these our geometric sequences. So to check if something is in fact geometric, again, you want to divide 2 consecutive terms. Now, again, it doesn't matter if we divide, for instance, the second over the first term, or maybe you are going to, in this case, do term 5 divided by term 4. Either way, what happens though, -9 divided by 3 or 243 divided by -81, what we're noticing is we consistently are getting that value of -3. So we know that, in fact, if we check this out, our R value equals -3. So this one is, in fact, going to be geometric. The next one, we are, again, if we test out 2 consecutive terms, we can do, for instance, term 2 divided by term 1. So if we take 1/4 divided by 1/2, we notice we're getting 0.5 or 1/2. We can also take, again, shouldn't matter here, maybe we do 1/16 divided by 1/8. If we check that out, 1/16 over 1/8. We should see, again, if the common ratios do in fact match. So 1/16 over 1/8 is also 0.5. So we see each time we are decreasing, we are multiplying by 0.5. So then this is also, again, going to be geometric. All right, now our explicit formula for our geometric is given here. And what we need each time is the first term, the common ratio, raised to the n-1 power. So again, some of these notations, we know a sub 1 is our first term, a sub n just means your nth term, r is your common ratio, aka what you're multiplying by each time, and then n is our number term defined. So how does this look in the context of the situation? So we see here a couple of these examples. So it wants us to start off by finding the common ratio. So again, to find the common ratio, we're going to take a term and divide it by its preceding term. So in this case, I'm going to do term 2 divided by term 1. I get my common ratio to be 5. The formula then, the explicit formula, I'm going to plug in my first term. I'm going to plug in that common ratio I just found. And then I'm going to leave this to the n-1 powered. This is as simplified as this gets. We don't have to worry about simplifying further. That is our explicit formula for this. Now to find the 8th term, we are going to then take our explicit formula and plug 8 in for n. So we could take 5 parentheses 3 to the a minus 1 power, or the 7th power, and we should get 10,935 as our final value there. I'm going to skip over number 4 for a moment and move to number 5. This time, notice we have some fractional values. So if we check out our common ratio this time, take term 2 divided by term 1, well, 1/3 divided by -1 is just going to be -0.3 repeating, better known as -1/3, right? We want to make sure we turn these into fractions when possible. So from there, that's our common ratio. We are next going to find the explicit formula, which again involves us just taking our first term times that common ratio to the n minus 1 power. And again, that is our explicit formula this time. Last but not least, we're going to calculate the 8th term again. So we're going to take our first term, our r value, and then to the n minus 1 power. What we're going to see is we're getting a really, really, really small number, 4.572 approximately, e to the -4th power. So that's just a really, really, really small number in our calculator. So we're just going to round to get that. All right, you try number 4 on your own. Check your answers. All right, number 6, okay? You should be looking for number 6 this time to find the first term. So notice this time they are giving us a sub 4. We know that we are looking for that first term, but we have a common ratio this time of -7. And again, they're not fully telling you, but you know your n this time is 4 if they gave you this subscript of 4, what this term is. Okay? So we can take, if we start simplifying, -7 to the n minus 1 power. So 4 minus 1 is 3rd power. You can just type that in. We get -343. And then in order to then solve, because again, we're multiplying these, we have -343. We can divide to get our a sub 1 by itself. So we're going to divide, and we have -2401 divided by -343. We get 7 as the value of our first term. Now on our next example here, we have, again, the 4th term being given to us. We do not know that first term. We know, though, that our r value is 1/2, and we're going to raise that to the n minus 1 power. Again, our n this time is 4 because they gave us the 4th term. Again, we can take our calculator and find what 1/2, to the n minus 1 power. 4 minus 1 is 3rd power. We get 0.125, or if you want to make that into a fraction, 1/8. Right? This is a nice terminating decimal, so it's a little less necessary. So we have 1/8 times a sub 1. And then last but not least, we can take -2 and then divide that. I'm going to put parentheses to make sure it does order of operations correctly, divided by 1/8, or 0.125, and we get our first term this time to be 16. All right, now the next section is asking us to work backwards. This time we are looking for the common ratio and then any of our missing term or terms in the sequence. So here's the thing. They gave us the first term on this one. We're missing the second term. We need the third, or we're given the third term. So similar to how we started setting up the others, we're going to start. We have our third term, first term, r, which we don't know, to the n minus 1 power. This time, our -75 is term 3. So again, we're going to keep those consistent, right? Well, this time, unfortunately, what we notice is we can't simplify this r to the third power and get like an actual number, but what we can do is just say 3 minus 1 is r squared. And in order to get r by itself, we're going to divide both sides by -3. -75 divided by -3 is +25. And then we can square root. So second x squared 25 to get our r value of 5. Okay, so each time, right, we are going to multiply by 5 to get our next term. So in this case, -3 times 5 is -15, and then we start seeing that pattern with the -75. Now on our next example, they gave us the first term. We're missing terms 2 and 3. This time we have term 4. So we're going to take -192, first term, r, and then this time our n is 4 because we were dealing with term 4. Again, we can't do much other than simplify that r is to the third power this time, which means to undo that multiplication again, we can divide by -3. -192 divided by -3 is 64. All right, cube root this time, right? We're undoing something to the third power, so we need to cube root. We've talked about this before. If you go under the math menu, you will see option 4 is your cube root button, and you can cube root 64 to get an r value of 3. Oh, excuse me, not 3, 4. Now again, we have this r value of 4, so we can take our first term, multiply it by 4, we get term 2 is -12. Multiply that by 4, we get -48, and then we see that -192. So we can fill in the -12 and the -48 as well. All right, last example. Okay, again, we have term 1 given. This time, though, we are missing terms 2, 3, and 4. We are given term 5 instead. Now, this is where things get even crazier because this time we can start things off again by dividing by the 2. Oops. So 2,592 divided by 2 is 1,296. And then these canceled, and we are left with r to the 4th, 5 minus 1 on this side. Now, you might notice there is no such thing on our calculator if we just go into the math menu as a 4th root. But what we can do instead is you type in the number 4, math button, and then you're going to scroll down this time to option 5, and it's going to plug that in for you. Or if you don't have pretty print, it'll store that for your x there. And we can type in, again, the 4th root here. Our number is 1,296. And the 4th root of that is 6. So again, we can undo this. 4th root, 6 is our common ratio. So next we have 2 times 6. And then we have 12 times 6. And then we have 72 times 6 until we start seeing that pattern go through for our last examples. All right, thanks everyone for watching. We'll work more with these in class.